Hello my Whoop friends. This video is part of a short video series where I try to share my experiences with the Meteor 75 Pro with you, as well as all my Whoop knowledge. I'll try to show you valuable tips and tricks that should help you with the Meteor 75 Pro Whoop as well as with other tiny whoops. Check out the other videos on my channel to get the most out of my many years of Whoop race and RC flying experience. Let's get started.
Who hasn't experienced this? We all have. After a few crashes, part of the tiny Whoop frame breaks. More precisely, a standoff. A flight controller standoff, also known as an FC standoff. Some call it a flight controller mount or even a flight controller pole. In any case, it's frustrating when the rest of the tiny Whoop frame is still intact, but you can't fly anymore because a flight controller standoff has broken off. The reason for this is a poor design of the FC standoff by some manufacturers. I once posted about this topic in the YouTube community section of this channel. And sometimes there's also a manufacturing defect, as you can see in one of my earlier videos. In that case, it was an air pocket in the material beneath the FC standoff. The solution from the manufacturer's vendor side would be to add a small radius or a thicker section at the base of the standoff. The Happy Model 75mm V3 frame, for example, has such a radius and thickening toward the bottom. I've never had an FC standoff break on that frame. It proves that it's technically feasible and that some manufacturers or frame designers have paid attention to these small details. Unfortunately, this knowledge somehow wasn't passed on within the company. Personally, I've lost hope that FPV companies will improve consistently. It feels more like a back and forth between progress and setbacks, maybe even on purpose. Maybe it's planned obsolescence, or maybe it's about never fully satisfying the customer so they keep buying new stuff. Either way, it's frustrating, which is why I went looking for my own solution and actually found one. The simplest and best solution to make FC standoffs unbreakable, in my opinion, is to drill them out with a sharp PCB drill and use an M1.2 or M1.4 titanium screw in combination with a plastic washer. This even works if the FC standoff is already completely broken. You can buy the PCB drills, titanium screws, and plastic washers on AliExpress. I'll list the links in the video description. In the video, I also show you how to make the plastic washers yourself. The big advantage of this solution is the very low weight combined with high durability. Especially the M1.2 version, which is absolutely sufficient for light one-cell tiny whoops up to 80mm, is extremely lightweight, much lighter than the original steel canopy screws and even more durable. Less weight and more strength. Pretty good deal, right? The M1.4 version isn't much heavier either, especially if the original FC standoff is already broken and no longer in use. At first glance, this solution may seem a bit expensive, but remember that it saves time and money in the long run because your tiny whoop frame lasts longer. In the long term, it's a very cost-effective solution for frequent pilots. So far, I haven't had any issues with this solution at all. But recently, on one frame, the material underneath the FC standoff broke during a really hard crash. Maybe it was just bad luck. This never happened on my old 75 Pro Whoop, despite many hard crashes. The difference was that on the old 75 Pro, I had cut away part of the plastic next to the FC standoff. That may have made the base where the FC standoff sits a bit more flexible, and that flexibility might have helped distribute the forces better. That's why I'll probably cut away the plastic again in the future and use the M1.2 version, which is also a bit more flexible. There are, of course, other possible solutions in theory, for some tiny whoops. But I think plastic screws in sizes M1.2 to M1.4 aren't strong enough. Not even Renmi screws. And M2 is already too large for many tiny whoop frames. Often, there isn't enough plastic to drill an M2 core hole. That's the biggest issue. The weight and strength of Renmi plastic screws would be acceptable for one-cell tiny whoops up to 85mm. The same goes for aluminum screws, but in M2 they're too big and too heavy. and I haven't found aluminum screws in M1.2 or M1.4 size. Please let me know in the comments if anyone knows a supplier for aluminum or titanium screws in that size. It's important to choose the correct length of the titanium screw for your tiny whoop. In my case, it's 8 millimeters. Ideally, it would be 7 millimeters, but that length isn't available from this AliExpress seller. It's important that on some tiny whoop frames, the end of the screw doesn't stick out too far from the plastic because it could damage the LiPo battery in a crash. You can also make the plastic washers yourself. It's quick and easy. The material can often be found in packaging made of 0.15 to 0.5 millimeter PET film. To make a washer, use a PCB drill to drill a hole in the PET film that matches the screw's core diameter. Then thread the titanium screw into the hole and cut out a generous square around it. Use pliers to hold the screw so that the distance from the screw head to the end of the pliers matches the desired washer radius. Then with a sharp electronic side cutter, trim the excess PET film in small steps, rotating the film slightly with each cut and using the pliers as a guide. And that's how you make your own ultra-light washer. Drilling the FC standoffs is pretty straightforward. What's important is to use a sharp PCB or carbide drill bit. These bits are extremely sharp but also brittle. Make sure there's no sideways pressure on the drill while drilling or removing it. Otherwise, it could snap. The diameter of the hole, or the drill bit, should be slightly larger than the screw's core diameter. Depending on the plastic used in the tiny whoop frame, the ideal size may vary. In my case, I used a 1.0 to 1.1 millimeter drill bit for the M1.2 titanium screws. You'll need to carefully test what works best. The hole diameter is correct when the screw can be turned in with moderate resistance, holds well, and doesn't overly stretch the FC standoff. The thread in the plastic forms during the first screw in. Ideally, you'd cut threads with a tap, but in my experience, that's not necessary. The screw should go in with medium resistance. Since I didn't want to shorten the titanium screw for the front FC standoff, I made a spacer from lightweight Depron material. Without the spacer, the end of the screw sticks out a bit too far and could possibly damage the LiPo battery in a hard crash. That's why I made the spacer. If you're using a 3-point canopy, it's important to tie the corner without a mounting point to the frame using dental floss. This helps relieve stress on the 3 other screwed mounting points. The forces on each mounting point are significantly lower with this dental floss method. That way, in the event of a crash, the impact forces can be distributed across 4 points. Ideally, of course, you'd use a canopy with 4 mounting points. Maybe those will be available again in the future, like the Happy Model Mobula 7 canopy back in the day. I know it's a bit of extra effort, but like so many things in life, a bit of effort up front pays off in the long run. All I can say is that this modification is worth it. With this video, I'm giving you a ready-made, solid, and proven solution. As a small bonus, I'll also show you the weight difference between a stock Meteor 75 Pro frame and one of my modified frames. I know it looks like a lot of effort for little gain, but for us pro racers, every 1/10 of a gram counts. Maybe we can't feel every 1/10 of a gram while flying, but just the increased awareness of how important weight is in racing motivates us to do everything we can to save weight. Also, it gives us the confidence that our gear isn't holding us back. And because we know that many small weight savings eventually add up to a 10 to 20% total weight reduction, that difference becomes very noticeable in flight.
In the coming months, there will be a few more videos about the Meteor 75 Pro. How you can modify it, how you can repair it, and so on. Stay tuned, my friends. And subscribe to the channel and set the notifications to on so you don't miss a single video. And last but not least, you can already find many videos of the Meteor 75 Pro on this channel in which I try to help you with this tiny whoop. Lots of tutorials, tuning tips, flight tips and repair videos. And there will be even more in the future if I am motivated enough by you, my friends. Stay tuned. Subscribe to this channel and activate the notification if you want to know when I publish a new video. And if you decide to buy a new Meteor 75 Pro or another whoop from Beta FPV, please use the affiliate link in the video description. This motivates me to publish more high quality videos. A like or a comment from you also helps motivate me to produce new videos with educational content. In other words, you will probably have the most videos for this whoop and the best support in the future if all goes well. I can't promise anything, but I'll do my best. The chances are good.
I've also made many other posts with educational content in my YouTube community. It's worth checking out the posts. There are even a few tips I haven't made a video about it yet. So be sure to check them out. Maybe you can learn something from them that will make your whoop life a little easier.
Happy flying, my whoop friends!